Hello everyone, my name is Mohit and I welcome you all to my YouTube channel. This is part 4 of SQL Server tutorial playlist, and in this video we'll discuss about the table constraint in SQL, which ultimately ensures data integrity. So what is this all about? Let us discuss. In my last video, I've discussed about creating and working with table in a very great detail. So if you have not watched that video, then I recommend you to watch that video as well. And also all my videos in this playlist are in sequential order. So if you are following that order, then you can get most out of it. Okay then. So these are the points which we are going to discuss in this video. We'll discuss what are SQL constraint, then what are the commonly used constraint, what is primary key constraint, what is not null constraint, what is unique constraint, and we will also discuss what is difference between primary key constraint and the unique constraint. Then we will go through foreign key constraint, default constraint, and check constraint. And also we'll discuss the syntax on how to create this constraint. Okay, so what are SQL constraint? By definition, SQL constraint are rules that define the properties and relationship of a data in database table, which enforces data integrity by limiting the type of data that can be inserted, updated, or deleted in a table. These constraint ensures that the data remain consistent and accurate according to the predefined rule. Okay, so if I summarize these 3 points, as of now, you can understand that SQL constraint are nothing but the rules that we implement on the data, that what kind of properties or what kind of relationship they should follow. Okay, so these things are taken control by SQL constraint only. Okay, so don't worry if you are not getting it now. As we move ahead in this video, you will understand everything in a more clear way and you will feel much more confident. Okay, so let me move to the next slide. So these are some commonly used constraint like a primary key constraint, not null constraint, unique constraint, foreign key constraint, default constraint, and check constraint. So what is primary key constraint? If you go through the first line, by definition, primary key constraint uniquely identifies each record in a table. What does this mean? So to make this clear, let me go here. So this is student table in which we have two columns, ID and name. And here ID is a primary key because PK is written beside ID. Okay. So if you observe carefully, in this column, ID column, all the values are unique. So if you want to identify any row of this table, you can uniquely identify it with the help of this ID column, correct? Let's say if you want to identify a row with ID equals 3. So this is the only row available in this table. Why? Because ID is a primary key and 3 is the only value available in this column. So by referring this ID key, you can uniquely identify this total row of table. Okay. So this is what the exact meaning of first line. Primary key constraint uniquely identifies each record in a table. Now, primary key column cannot contain duplicate value or nulls. Each value in primary key columns must be unique and not null. So that's what we have discussed here. So here every value is unique, right? So if you refer this second table, we are trying to insert this null value in fifth row. Fifth row, assuming ID is a primary key of this table. So if you try to insert this row with ID value as null, this DBMS will throw an error. Okay. Similarly, if you try to insert a duplicate row, why I'm saying duplicate row? Because in this third table, if you observe, we already had ID value as 4 and we are trying to reinsert this value. So again, DBMS will raise an error. So this was the meaning of second line. And here we have mentioned column or columns. If you observe this second line, we have mentioned column or columns. So in this example, ID column is a primary key, correct? But in real-time example, the combination of multiple column can create a primary key. Okay, there would be only one primary key constant, but that constant can be created using multiple columns. So in this case, we are only using ID column to create primary key constraint. That means we are only using one column to create primary key constraint. But in real time, we can use multiple column to create primary key constraint. And in one table, we can only have one primary key constraint. But yes, that constraint can be created using multiple columns. Okay. Now, if you observe this third point, if an attempt is made to insert a row with duplicate primary key value or a null value in a primary key column, the DBMS will raise an error. So that is what we have discussed in this second and third table, right? Here we were trying to insert null value. Here we were trying to insert duplicate value. So in both the cases, if ID is a primary key, DBMS will raise an error. And that is what we have mentioned in third point. Now, fourth point is a bit important. What is this? A primary key constraint automatically create a clustered index on primary key columns. So what is cluster index? We will see. So by creating cluster index, this helps improve query performance by organizing the physical storage of a table's data based on primary key values. And see, in last point we have discussed what is cluster index. Cluster index determines the physical order of a rows in a table on disk, which can improve the efficiency of data retrieval operations like searching and sorting. Okay, so what does this 2 point means? Let us understand. So here in right side, you can see that we have a table called student, and we have inserted 4 rows. And this is the order like ID 2, then 1, then 4, then 3. So these are the 4 rows. So as soon as you mention that ID is a primary key, internally it will create a cluster index, and that cluster index will do what? That cluster index will physically store this data in a ordered manner. So here if you see this, due to this cluster index creation, this ID column value is stored in a ordered manner, 1 2 3 4. And if it is stored in an ordered manner, so of course whenever you try to query or whenever you try to search some ID, it can follow that order, and that search operation can become very fast, right? So that's what we here we have mentioned, that cluster index determines the physical order of a rows in a table or disk, which can improve the efficiency of data retrieval operations like searching and sorting. Okay, so because of this cluster index creation on primary key, the data retrieval operations will become very fast. Okay, now let us move to the next point, which is how we can create a primary key constraint. So this is the syntax. In our previous video, we have already discussed how we can create table using SQL query, correct? So let's say you are trying to create the same student table in which student ID is primary key. So how you can create a primary key using SQL query? This is the way. Like everything would be same. The only keyword we need to add is primary key beside this column. Okay. It will create a primary key constraint on this column. And also we discussed that we can have only one primary key constraint in one table. But yes, that constraint can be created from multiple columns, right? So in left side, we have used only one column to create primary key, which is student ID. But if you want to create primary key using multiple columns, so here's the syntax, what you can use. Like you can write a create statement for that table. And at the end, we just need to mention this primary key, then the set of columns using which you want to create primary key constraint. So this is the way how we can create primary key in both the cases. Okay. Now let's move to the next part. Okay, so now what is not null constraint? So from the word itself, it is clear that by creating this constraint, it will not allow null values, right? So this is what we have mentioned here. Not null constraint ensures that a column must always have a value, disallowing null entries, and it helps maintain data integrity by enforcing the presence of valid data in specified column. So what is the use of this? It is explained by second point. Let's say in some column you want valid data. You don't want that data to be null value. So there on that column you can create not null constraint. So this constraint will ensure that there will be only not null entries. Okay. So here again we have the same table, student table, in which we have two column ID and name. And on this ID key we have created not null constraint. That means it will not allow null value. Correct. And that is what we have shown in this right table. If you try to insert null value in this column, which is having not null constraint, DBMS will raise an error. Okay. Now, how we can create not null constraint? Again, along with the create table script, you just need to add not null keyword. Okay. So if you add not null keyword, not null constraint will be created for that particular column. And of course, we can create this constraint in multiple columns. So here, in this case, we have created this in student name, age, and enrollment date. Okay. So this student table is different from this example. Here I have taken only two columns to make it simple. Okay. But in this case, I have considered this four column in which three are having not null constraint. So whenever you try to insert null value in these columns where we have defined not null, DBMS will raise an error. Okay. So that's what we have mentioned below. The student name, age, and enrollment date columns are marked with not null constraint. This means that when inserting data into this table, value for these columns must be provided and they cannot be null. Correct? Now let's move to the next slide. Unique constraint. So here also by the name itself, it is clear that this will only allow unique value in that particular column where we have created this constraint, right? So the same thing we have written, like this ensures that all values in a column or set of columns are unique. So in this table, if you observe, again, we have taken the same table, student table, in which we have created a unique constraint on ID column. So if you observe carefully, all the values are unique. They are not getting duplicated. And also it can allow a null value. Okay. So you cannot duplicate the value. Otherwise it will throw an error. So every value in this column on which we have created unique constraint must be unique or distinct. Okay. And in second point, we have written in SQL Server, by default, only one null value is allowed. Okay. So if you are creating a unique constraint on top of ID column, you can only insert one null value. And if you try to insert multiple null value, then it will throw an error. But of course, by doing some kind of extra setting, we can also insert multiple null values. But by default in SQL Server, it allows only one null value. Okay. So again, what is the syntax of creating unique constraint? This is here. So while creating a table, let's say you want to have a unique constraint on this mail ID, last column. So only single keyword you have to use, that is unique. So if you use this keyword, it will create unique constraint on top of this column, which is mail ID. And this will ensure that only unique values are there in mail ID column. Okay. So what is the functional use of this one? It is written here. Mail ID column has a unique constraint. It ensures that each student's email ID or email address is unique, preventing multiple employees from sharing the same email. So of course, every individual should have their unique mail ID. So we can ensure this by creating unique constraint on this mail ID column. Now, what is the difference between primary key constraint and unique constraint? So this might be confusing that by creating these two constraints on top of a column, unique values are only allowed. But what is the difference? So if you have observed carefully, then in primary key, while inserting null values, it was throwing error, correct? But in case of unique key, it can allow one null value, right? By default, it can allow one null value. So this is the difference, that in primary key, you cannot insert null value, but in case of unique constraint, by default, one null value is allowed. Okay. So this is the main difference between primary key constraint and unique constraint. Now coming to the foreign key constraint. So what is foreign key constraint? By definition, it enforces referential integrity by creating a relationship between two tables. So what does this mean? Let's say we have two tables, customer and orders. Okay. So by creating a foreign key constraint, you can ensure referential integrity. Let's say you have two tables, customers and orders. And in customer table, you have customer ID and customer name. And in orders table, you have details about order along with customer ID. So if you create foreign key constraint on this order table, and this is how we can create foreign key. Let's say you want to create a foreign key referencing customer table. So this is how we can create foreign key constraint. So create table orders, then we can provide all the columns. And then in the end, we can write foreign key, then on which key we are creating foreign key. So in this case, it is customer ID, which is second column, right? And this second column is referencing which column of which table. So this is the detail of table and column this customer ID is referencing. So it says that references customers, which table name, then in bracket column name of that table, that is customer ID. So this will refer this customer and customer ID, this one. Okay. So this primary column will become foreign key to this table. Okay. So we'll see these things in a very great detail in our upcoming video. But just to understand, in short, if I say, let's say customer ID 1, 2, 3, and 4 are present in customer table. So in order table, if you are creating foreign key constraint, it will only allow those values which are already present in customer table. That means it can only allow 1, 2, 3, and 4 because this we are present in customer table, that is first table, right? So in order table, you cannot insert customer ID with value as 5 because if you try to insert that in order table with customer ID 5, it will throw an error saying foreign key constraint violation error. Okay. So this is what we have tried to explain here. The customer ID column in orders table is foreign key referencing the customer ID column in customers table, which is first table. Okay. So what it will do, it will ensure that each orders is associated with an existing customer, maintaining referential integrity. Okay. So that's what we have discussed. Let's say customer ID 1, 2, 3, and 4 are present in first table. And if you want to insert customer ID equals 5 in order table, it will not allow. Why? Because it will break that referential integrity. It will refer this customer ID column. It will check whether the value are present or not because we have created this foreign key constraint. Okay. And this constraint will ensure that, yeah, only those values should be inserted which it can refer from the first table, that is customer table, on which we have created this foreign key constraint. This is the simple meaning. Okay. So again, don't worry. We'll understand these things in a very great detail by taking some practical examples in our upcoming videos. Okay. So let's move to the next slide. Now, default constant. What a default constant means? By definition, it specifies a default value for a column when no value is explicitly provided during insertion. So this is simple. Let's say you are creating a message table, okay, in which these are the list of columns. And in last column, which is message underscore status, let's assume that in case no value is provided, you want to insert a default value which is unread. Okay, so this is the default value you want to insert in this table whenever no value is provided in message status. This column, last column. Okay, so to achieve this kind of requirement, you can use default constraint. Okay, and how we can create default constraint? This is the syntax. In last column, message underscore status, we have tried to create a default constant. So we can use this keyword default, then the default value which you want to insert. Okay, and rest everything will be same. So on creating this table, it will create a default constant on message status column. Okay, so this is the same thing what we have written here. Here the message status column has a default value of unread. If no value is provided during insertion, it defaults to unread, ensuring that all the messages start with this status. Okay. So this is the exact thing what we have discussed, right? Now let's move to the last constraint, which is check constraint. So again, by word it is clear that this constraint is defining some kind of condition on top of columns, that what kind of value or what is the range of value it can accept. So if you go through the definition of this, it says it defines a condition that must be met for data to be entered or updated in a column. This check constraint is used to limit the value range that can be placed in a column. Okay, so this is again simple to understand. Here we have tried to create a product table. So everything is same like create table script. But if you want to provide a check constraint on some column, so in this case, we want to create a check constraint on price column. Okay, and the condition is price should be always greater than 0. Correct? In real time also price cannot be negative. price of a product cannot be negative. It should always be some positive number, right? So to ensure that, we can create a check constraint on price column, and this is the syntax to create it. So along with all the columns, while creating a table, we can just add this part, that is check and then condition. And here condition is price greater than 0. Okay. So this will create a check constraint on price column, and it will ensure that the data in this column will always be greater than 0. Why? Because we have created check constraint on price column. So this is what we have tried to explain here. The check constraint ensures that the price of a product is always greater than 0, preventing the inserting of invalid or negative prices. Okay. So this is the use case of check constraint. Okay. So today I only tried to explain the theory behind these constraints. In our upcoming videos, you will see these things in a great detail with some practical examples also. Okay. So that's it for this video. Thank you so much for watching it. If you like the content, then please don't forget to subscribe to my channel and press the bell icon to get the new video updates. We will meet in our next video with a new concept. So please stay tuned. Till then, take care and goodbye.